Hi, year 11s. So we continue with chapter 3, which is about quadratics. Previously, we looked at factorizing quadratics, solving quadratic equations. Lastly, we look at the graph. Today, we're going to look at completing the square in terms of connecting that to quadratic equations, but also with the graphing with the turning point form. So previously we looked at when we have a perfect square like this and we expand it, um, you will have this form. Notice how the middle term is, hold on. Notice how the middle term is you double the terms as a product. Now, what we're going to do is rearrange that equation by minusing the a squared, or we do a transposition. They will cancel out on the right hand side, and on the left we'll have a difference of two squares. Um, I just rearrange that expression to be on the left. So we swap it around just to make it look the way we're going to start the square process. Before I move on, and I'll explain that how we continue with factorizing and solving if it is an equation. Okay, just be mindful of the language I'm using. Um, this is an expression. When we have that equal in terms of y equal, it's a function. And if all of that is equal 0, this is when we have an equation. Do you remember? So we have that quadratic equation equals 0. You do need to remember also that it is a perfect square. To find the missing term here, sorry, that one, what you would do is look at the 2x, half it, you square it to obtain this one, or you can substitute in here, which is your perfect square. Then, going back to the previous equation, we write our perfect square by having the plus 1 minus 1, which is the half term that is squared, which is this one, and you subtract this exact same amount. The three terms on the left-hand side will be equal to that perfect square, which is factorized. And the two terms on the right, the negative 1 and the minus 3, we combine them together to form we just combine them. Okay, so it's just adding, subtracting numerals. Um, that is our difference of two squares as an equation that equals 0. Then what you'll do is apply the difference of two square formula, and that will be, remember, that's your a squared minus b squared. So the 4, you need to turn it into a square form. As it is a perfect square, that is equal to 2 squared. If it wasn't a perfect square, what you would do is just write a third form, and don't forget to simplify. And there's an example coming where there will be a simplification. You have your a plus, or here it's a minus b, and then your a plus b. You simplify each expression, and then you apply the null factor law by making each factor, so the whole expression on the left bracket, on the right bracket, each one of them need to be equal 0. You make x the subject, you end up with x equals 1 or x equals negative 3. So this is something that we have done before with solving equations, and we just focus a bit on the completing the square. Another example. So we have a quadratic expression. Notice it's a monic expression, so there's a 1 in front. Now it's an equation, so it's equal 0. When you have that number, the coefficient being odd, you're going to end up with a fractional form. So we divide by 2 and you square it. Something that I should have done here is, let me annotate that. So inside the bracket next to the 7/2, it is a negative. The reason why I didn't add it in is because when I square it, the negative times the negative is still positive. So it wouldn't matter for this form. But when you write it in a perfect square form, when you take that coefficient divided by 2, that will make a difference in your perfect square. So let's continue with that. We evaluate that fraction that is minus itself. So that's 49/4. The 1, you're going to write it as an equivalent fraction over 4, so you can evaluate the last two numerals. The three first term are a perfect square. It will be a, so that's regrouped. It will be a 7/2, so fractional form, and there is a minus that I added over here before, but the square will turn it into a positive. So you have your difference of two squares here. You need to turn that into a square. So you would have the denominator is a square, so perfect square, so that would be 2 squared. And this one will be square root of 45 squared. And it's also the product of 9 times 5. So the 9 is a square that will give you 3 root squared, the bracket, and a square on the outside. Difference of two squares. Let me go back. We have a difference of two squares. We'll apply the North factor law, and we can find the solution of that equation. I don't need to continue that because we'll focus on that, keeping this form for the turning point form. But you should be able to continue that on your own, and the answer will be a third form with a fraction over 2, and it will include a root 5 for the two solutions. Example 3. Now it's a non-monic quadratic. There's a 3 coefficient in front, but the right hand side is equal 0. So what I'm allowed to do for that whole equation, I'm allowed to divide by 3 on both sides. What it will do is it will turn that into a monic quadratic, and then you're going to have residual fraction or coefficients. The right hand side will still be 0. So 6 divided by 3 will give you 2. Sadly, we get a 4/3. So again, you will have to deal with fractions. Let's turn that into the first two terms. We need to add a third term to make it a perfect square. So the 2x, we divide by 2 and x, that gives us 1, and we square it. Okay, so that's 1 squared, and that's 1 squared. We evaluate each one of them, that's 1 and 1. The first three forms will be in bracket, that will be a perfect square. The last two numerals, -1 plus 4/3, we need to combine them together. So the 1 needs to be turned into an equivalent fraction, which is -3/3. Yes, that's a step. So that's -3/3. The trinomial, the first three terms will be x plus 1 bracket squared, and we evaluate the sum of the fraction, that's 1/3. So that's plus 1/3. To continue with that equation, is that a difference of two squares? Because it's not, it's a plus, you can't factorize it the way it is, so you can stop and write down that there is no solution for that equation. So you won't find any values of x that you can substitute into that expression to make it equal 0. All right, let's look at the turning point form. So the idea is you have a function, so y equals, you have a quadratic expression in the form ax squared plus bx plus c. Before you complete the square, always factorize the coefficient in front of the x squared. If it's a 1, you don't have to worry about it. Otherwise, you need to do so. Factorize it, and the other terms, for the x term and the constant, you will have a fraction over a. And then you will complete the square by creating a third term. That b over a, you divide by 2 and you square it, which is what we get over here. And then we minus by itself, so that those two cancel out, that equals 0. What am I doing is creating a trinomial. That trinomial is a perfect square. And then what you would do is you would combine those two together, evaluate, to get that external constant. Now what I did here as well is to go from here to there. What I did is they expanded the bracket. So that external bracket, that large bracket, on the next line doesn't exist. There is another bracket that starts with, but it's actually the bracket for that perfect square. So what they did is they multiply a with those three terms, which is your perfect square. And when you multiply a with minus b squared over 4a squared, you end up with minus b squared over 4a. And the last term, which is c over a, when you multiply by a, that just gives you plus c. So this is an important step, and I'll show it to you that if you don't do that step properly, you end up with a mistake at the end for your turning point form. Let's revisit the two examples that we used before to solve the quadratic equation. So that equals 0. We introduce the third term. We create a perfect square, and this is this difference of two squares. But let's stop here. And the left-hand side is showing you the turning point form. So if I have the function, which is the same as or the expression from that quadratic equation, we have that exact same form. And from here, we can read the coordinates of the turning point. So that will be -1 for the +1 here and -4. So the coordinates of the turning point are listed below. This time you have another example we did before when we have a non-monic. So we need to factorize that a term. When you have an equation, what you did instead is you divide by a. So what we did here is we divide by 3. Okay, that is for the equation. We end up with this expression, but that expression was actually divided by 3. So if you were just to use this one, you would ask yourself, what are the coordinates of the turning point? If you read that out, you will have -1 and a third, and that will be incorrect. So what you will need to do is from that equation is multiply the whole expression, ignore the equation, the part with the equals 0, all of that will give you 3 brackets squared, but that one, the 3 times a third is equal to 1. The turning point is -1 and 1. So it doesn't change the +1 here inside the bracket of that square, but it changes the y coordinate. Okay? And that's it for 3e, and I'll see you later.